Okay, when water leaks through a hole in a tank, the volume of the water leaving the tank per second is given by dV dt, which is equal to C times A of 0 square root of 2gh, where the C is some number between 0 and 1 is called a friction constant. G is gravity, so it's 32 feet per second squared. H is the height of water above the hole, and A of 0 is the area of the hole. Okay, so let's look at an example now. So I'm going to erase this and write my example up there now. We'll be using this in our example. Okay, so let me write the example. Okay, so here's our example. It says a right circular conical tank, a radius 10 feet and height 15 feet, loses water out of a circular hole at its bottom. If the radius of the hole is 1 inch and the friction constant is 0.5, find a differential equation for the height of the water at time t. So let me first draw a picture of this. So here's a picture. So it's radius 10, height 15, and there's a hole at the bottom, so it's going to start going down the water level. So say here's the water level at time t as radius r and height h here. So let's make an observation. So in particular the radius, so the 10 over 15, that ratio should be the same as the r over h. So let me write that right here. So we have 10 over 15 equals r over h. We can then solve it for r by multiplying. Let's multiply both sides by h. So it's to solve for r. So doing that, we can then get r equals 10 over 15h, or that reduces crossing 5's off, 2h over 3 equals r. And now we're going to use the formula for the volume of a right circular cone. So let me write the formula up here now. So this is the formula for finding the volume of a right circular cone. It's going to be pi r squared times h over 3. But now I want to get rid of the r squared here, so I'm going to replace my 2h over 3 with the r right here. So let's do it right here. So doing that, we get then pi. So in place of r, you're writing 2h over 3. So it'll be 2h over 3 squared times h over 3. So squaring 2h will become 4 h squared. There's another h here, so it'll be h cubed. And then it'll be 3 squared times 3. So it'll be 3 cubed, so it'll be 27. So it's going to be 4 pi h cubed over 27. Okay, now we're going to take the derivative on both sides with respect to t. Okay, because we're assuming that the volume and the height are functions of time, because when time is changing, the water level is dropping in the tank over here. So we're going to take derivative with respect to t on both sides. Yeah, so we're taking derivative with this means with respect to time on both sides. So doing that, on here we'll have dv dt, and here we'll have to use the chain rule. So it's going to be, bring the 3 in front, it'll be 3 h squared times dh dt. So let me write it right here. Okay, so taking derivative of e will be dv dt, and taking derivative of h cubed will be 3 h squared times dh dt, and this whole thing will reduce then to 4 pi h squared over 27 dh dt. Okay, now in place of the dv dt, now we're going to make a substitution. So now in particular for dv dt, we're going to use the first equation I've written on here at the beginning of this video, that dv dt equals c area of the hole times square root of 2gh, where g is the gravity. So here our c value is 0.5. That's given in the question. The friction coefficient was given as 0.5 up there. So back up here, right here. And the radius of the hole was, like up here, was 1 inch. So we can find the area of the hole here. So let's find the area of the hole. G is 32 feet per second, so let's make some observations here. Okay, so the area of the hole then will be pi r squared, but the radius is 1 inch. We have to change it to feet, so it'll be 1/12 of a foot. So it'll be pi over 1/12 squared, so it'll be pi over 144. G is 32, or C value is 0.5. So let's make those substitutions up here. So making the substitutions, we get this. Now the square root of 64 is 8, and it'll be 8 times 0.5 will be 4. So let me simplify this a bit further here. So I get then 4 pi square root of h over 144. 4 into 144 will be 36, so it'll be pi. I'm going to write the square root of h as h to the 1/2 over 36. Now this can go in place of the dv dt here. So let's do that. So I'm making a substitution here. Actually, I just noticed something here. This 3 should have crossed off with the 27 here, made a 9, so there should be 9 here actually. And this would be 9 here also then. Okay, so let's keep going then. So I want to solve for dh dt, so it's multiplied by reciprocal of this guy over here. So doing that, we get then so solving for dh dt, so multiplying by reciprocal of this on both sides, we'll have this, and the pi's will drop off. 9 into 36 will go 4 times here. And then you'll have h to 1/2 and h squared down here. So this will be 1/2 minus 2, so it'll be minus 3/2. So let me write the final answer then here. So I'll have 4 times 4, so 16, and again h to the 1/2 minus 2. Well, 3 you can write as 4 over 2, so it'll be 1/2 minus 4 over 2. So it'll be minus 3/2 then for the h, the exponent. So that's our differential equation then. So dh dt equals h to the minus 3/2 over 16. So that answers the question, so we're done. Okay, so I'm going to stop the video now since we're done. Okay, so the video is over.